This is video number 1 for section 6.8, and in this video we're going to be focusing on the first objective for the section, which is being able to build functions given rational, irrational, and complex roots for them. Okay, so let's begin with a theorem. It's called the conjugates theorem, and this theorem says that irrational and complex zeros of a polynomial function, they have to come in conjugate pairs. Okay. So first thing to notice is that this theorem only applies to irrational and complex zeros. It does not apply to rational zeros. Okay. Let me give you some examples of the theorem at play. Let's say that 2 plus 3i is a zero of your polynomial function f of x. Well, 2 plus 3i is a complex number. That means its conjugate of 2 minus 3i is also a zero. And notice what it means to be a conjugate. You're simply changing the sign on the imaginary part of the complex number. Second example, if negative 3 minus the square root of 5 is a zero of g of x, then what else is a zero? Well, negative 3 minus the square root of 5 is an irrational number. Its conjugate would also be a zero from this theorem, which would be negative 3 plus the square root of 5. You're only changing the sign on the square root portion of the irrational number, okay? All right, so we're going to utilize this theorem in the coming examples. Build a polynomial function f of x in standard form of least degree with integral coefficients that has zeros of 3 and 2i. Now, there's a lot going on in those directions, okay? Let me break it down for you. Standard form basically just means the expanded form of the function rather than the factored form, okay? Of least degree means build the function with the smallest degree possible that has zeros of 3 and 2i. Technically, there's an infinite amount of functions out there that would have these zeros. We just want the one with the smallest degree possible, okay? And then with integral coefficients means integer coefficients. So that implies no fractions or decimals can be used for our coefficients, okay? All right, so here we go. First thing I'm noticing is that out of the two zeros that were given to me for this function, 2i is the only one where I can use the conjugates theorem. The number 3 is a rational number. Conjugates theorem doesn't apply to rational numbers, but 2i is imaginary, and I can use the conjugates theorem on that. So the first conclusion I'm going to draw is that the conjugate of 2i, which is negative 2i, is also a zero of the function f of x by the conjugates theorem. All right, so technically there's 3 zeros to this function, and if there are 3 zeros, then that means the least degree right here in the directions would have to be a degree of 3, okay? Because the number of zeros should match the degree. All right, so we start to build the function f of x in its factored form. Each zero can lead me to a linear factor of the function. So if 3 is a zero, then x minus 3 is a factor, okay? If 2i is a zero, then x minus 2i is also a linear factor. And if negative 2i is a zero, then x plus 2i is a factor, okay? Now don't overcomplicate that. Notice what I've done. I've simply taken each zero that I knew for the function, and to build a factor, I simply subtracted that number from x, okay? Now the task is to multiply these 3 factors together so that I have the function in standard form, okay? I'm going to multiply the two conjugate factors together first, okay? So that means I'm going to multiply x minus 2 with x plus 2. Reason I start there is because conjugates, when I multiply those out, I only have to do the first and last parts of the distribution FOIL process, okay? So just carry down the x minus 3, and then x times x, of course, is x squared. Negative 2i times 2i is negative 4i squared. Now, negative 4i squared, you can simplify. Remember, I squared equals negative 1, so negative 4 times negative 1 is giving me positive 4. Okay. At this point, should be smooth sailing. X minus 3 multiplied by x squared plus 4. You're going to FOIL that out completely now. Okay. And that's going to lead me to x cubed minus 3x squared plus 4x minus 12. And there's the function that I'm after. Notice it's in its standard form. And look at the degree of the function. The degree is 3, which matched what we said based off of the fact that the function had 3 zeros to it. Okay? All right, second example. This one's going to be a little bit more involved, but not too bad. Build a polynomial function g of x in standard form of least degree with integral coefficients that has a 0 of 2 plus the square root of 3. Okay, so we're only given 1 0. 2 plus the square root of 3 is one irrational 0. Okay, I can use the conjugates theorem on that and say that 2 minus the square root of 3 is also a 0. I can do that because that was a irrational number. All right. Since there's only 2 zeros known, that means the least degree has to be 2. Okay. Least degree is going to be 2. All right. So I build the function g of x by taking each of these zeros. Change colors here. I take each 0 and I subtract it from x, okay? And understand, so if your 0 itself is presented as a binomial, what I mean by that is 2 plus the square root of 3 is a binomial. When you subtract that from x, you need to put that whole number in parentheses. And then we're going to put brackets around that to show that x minus the quantity of 2 plus the square root of 3 is a factor. And we'll do the same thing with the other 0. So I take x, I subtract it by 2 minus the square root of 3. So there's your two quadratic factors. And now the tough part is in being able to multiply this all out. Here's a trick, okay? Pay very close attention because we're going to use the same trick in the next example as well as your practice problem, okay? So whenever you're taking x and you're subtracting it by a binomial number like this, we're going to begin by distributing this negative sign here as well as here, okay? So that's going to lead me to x minus 2 minus the square root of 3, as well as x minus 2 plus the square root of 3, okay? Now, technically, when you distribute those negative signs, the parentheses clear, they go away. But I'm actually going to bring them back into play because you, in each set of brackets here, you have 3 pieces working together with addition and subtraction. Whenever that's the case, you do your addition and subtraction from left to right. So that means I'd be working with x minus 2 first before subtracting by radical 3. And then the same thing over here, okay? So what I've just done by distributing the negatives and then shifting the parentheses over, this process is known as regrouping. Okay, what we've done to go from here to here is used regrouping. Okay, And regrouping is very helpful in this situation because notice that this set of brackets as well as this set of brackets, the only thing that's different between the two is the sign in the middle, right here and right here. So that actually tells me I'm working with conjugates. And I like conjugates because when I multiply them out, the outside parts of FOIL and the inside parts of FOIL cancel each other out. So knowing that, that really means I'm only going to have to multiply out the first part of FOIL, which would be x minus 2 times x minus 2, and then the last part of FOIL, which would be negative radical 3 times positive radical 3. Okay, so here's what that'll lead me to. It'll give me x squared. X minus 2 times x minus 2 is going to give you x squared minus 4x plus 4. And then negative radical 3 times positive radical 3 is just going to give you negative 3. Okay? And then, of course, 4 minus 3 is 1. So our function g of x that has these two zeros is right here. Notice the degree is 2, which we stated at the beginning of the problem is what it should be. All right, let's take that process one step further. Same directions. Build a polynomial function h of x in standard form of least degree with integral coefficients that has zeros of negative 2/3 as well as 3 plus 2i. So I'm given two zeros. Of those two zeros, the only zero that the conjugate theorem can apply to would be 3 plus 2i. So right off the bat, I'm making a conclusion that 3 minus 2i is also a 0. Okay, and now since I have three zeros, least degree of this function is going to be 3. So let's build 3 linear factors for this function, h of x. If negative 2/3 is a 0, here would be where the integral coefficients portion of the directions should come into play. So your one option is you could say that x plus 2/3 is a factor, right? You just simply subtract negative 2/3 from x to build your factor. But the issue with leaving it like this is that when you multiply it out with the other two factors that the function will have, you won't have integral coefficients, okay? So instead of using x plus 2/3, let's use the factor 3x plus 2. Wouldn't that also lead you to a 0 of negative 2/3 as well? All right, and that's going to ensure you have integral coefficients, okay? My second factor, I'll take x, I'll subtract it by 3 plus 2i. And then my third factor, I'll take x and I'll subtract it by 3 minus 2i. So now the trick is in multiplying this all out. All right, I would multiply the two sets of brackets first, and to do that would require the same regrouping process as the previous problem. So I'll distribute these negative signs. I'll just carry down the 3x plus 2 here, and then when I distribute those negative signs, that allows me to shift the parentheses or regroup them around x minus 3 in each set of brackets. Okay, so now this two sets of brackets are conjugates. I can do first and last parts of FOIL. Okay, so you're going to take x minus 3 times x minus 3. That's going to give you x squared minus 6x plus 9. And then negative 2i times 2i is going to give you negative 4i squared. Okay. Carry down the 3x plus 2 again. And then understand that 9 minus 4i squared is really 9 plus 4. So you end up with a 13 here. All right, so hopefully at this point it's smooth sailing. You now have a binomial times a trinomial, and you're just going to use the distributive property a total of 6 times. 1, 2, 3, 4, 5, 6. All right, so that's going to lead you to 3x cubed minus 18x squared plus 39x plus 2x squared minus 12x plus 26. And then combine your like terms. So negative 18x squared combines with 2x squared. 39x will combine with negative 12x. And in the end, we'll say h of x is equal to 3x cubed minus 16x squared plus 27x plus 26. Notice the degree of that function is 3 to match the fact that the function we knew had 3 zeros from the beginning. Okay? All right, your turn. Try the practice problem. It's going to take you a few minutes. If you get stuck, I would refer back to either this example or example 2 as a little bit more help, okay? So pause the video, work through that yourself, and then come back and check your work with mine.